Thank you, Janine. As Janine said, we're headed to Tewkesbury in the United Kingdom, home of Trackwise Designs plc. Trackwise was formed in 1989 as a printed circuit board design house and found a niche as a build-to-print supplier for the telecom industry. In 1996, the firm produced its first antenna PCB, a 9-foot-long unit for a 900 MHz GSM base station. The need for long, flexible printed circuit boards led Trackwise to develop improved harness technology, a name understating the patented capability to produce flexible PCBs of unlimited length. Philip Johnston, the CEO of Trackwise, explains how improved harness technology, or IHT, eliminates length as a constraint.
Quite a number of the printed circuit board manufacturing processes are length agnostic, so the typically horizontal conveyorized machinery spraying chemistry or rinse water onto a panel going through this horizontal line. But some of the process steps are what we would call static in nature. So those are typically during drilling, during imaging, during pressing, and the size of those manufacturing, the manufacturing equipment used during those processes defines the size of the circuit. And the vast majority of the world's manufacturers, that size limit is 2 foot in length. That's typically because it's a quarter sheet of a 4 foot by 3 foot sheet, so it works out as 4 panels of 24 by 18 inches. And this standard really has become the global standard in the size of products that you're making. So if you want to make a larger circuit, and Trackwise has had the capability to make products up to 2.8 meters, so roughly sort of 7 foot in length for some 25 years now. If you want to make bigger boards, you have to buy a bigger piece of equipment for those static steps. So a bigger drill, a bigger imaging device. So if we want to think about making length unlimited, you either buy a bigger drill and yet a bigger drill and yet a bigger drill, and eventually that becomes impossible, or you choose a different approach, and that is to look at it as a dynamic process and adapt the manufacturing processes to be length agnostic, to be length unlimited. And whilst it's possibly easy to say that is the challenge that we focused upon and have met.
So what were some of those challenges to developing improved harness technology?
So what we have done, without giving too much of our secrets away and all the blood, sweat and tears that we've spent over the years, so the main thing was a look at existing reel-to-reel manufacturing processes and understand whether those could be adapted to length unlimited. So flex PCBs are made in volume in reel-to-reel manner, but those are typically repeated circuits separated by a small amount. And so what we've done is we've worked with the equipment suppliers to adapt existing roll-to-roll machinery to be able to cope with our demands of length unlimited. I'll use a handy little prop. So normally in a roll-to-roll manufacturing process, you've got 2 identical panels going slightly separated from each other, going through a roll-to-roll line. For our length unlimited, we've got 2 non-identical, immediately adjacent panels. So the trick was to turn this process into this process. So, and that involved finding and working with innovative equipment suppliers who prepared to change their software, to change their equipment to accommodate that. So a big challenge was finding like-minded, innovative equipment suppliers, which I'm pleased to say we worked with some very good people to help us realize this ambition.
To get a better sense of Trackwise's capabilities, we asked Philip to show us the key manufacturing steps in the IHT process.
This is an image of one of our development engineers loading up the laser reel-to-reel drill. So this is showing the dancer, which is controlling the tension of the material as it goes into the laser drill. This is used both at the start of the process and the end of the process. At the start of the process, we're typically putting in tooling holes in the material. I think that the laser itself is a relatively standard one that has been adapted for roll-to-roll operation. After drilling, the product comes through the pre-clean line. Obviously, copper tarnishes relatively quickly. Here we're laminating on the UV sensitive film in the Class 7 clean room that we've implemented. This is a relatively standard process in most companies. Again, one of the length agnostic processes that we mentioned earlier. So this is now our reel-to-reel direct imaging machines. The process on the left is the unwinder. It then goes through the imaging section and through to the unwinder. So this is material being wound into the machine. And this is a shot of the inside of the imaging section. You can see the UV heads on the left of the machine. This gives us capability to image down to as low as 50 microns or less, so 2 mil or less, but is a very high capacity machine as well. This has produced a very significant increase in capacity for us. UV applying the light to the film, defining the image of the circuit. And then this is after imaging the circuit, continuing to go through the roll process. Wound onto the spool at the end of the process. And you can vaguely make out the circuit shapes underneath the dry film cover layer. So this is etching the unwanted metal from the circuits. This is an oscillating vacuum etcher. Looks like something had a blade run in it, doesn't it? So this is rinsing off the circuit prior to drying, prior to the end of the circuit. These are horizontal conveyorized equipment. So this is what I talked about earlier, that they are length agnostic machines. So we're coming down the develop etch strip line, the stripper and the wash section and the dryer. This is showing a microstrip antenna circuit. This is one of our inline inspection steps, inspecting the track width of a microwave antenna circuit. This looks like a small cell antenna circuit which we're supplying into a number of antenna circuits. My colleague running the etch strip line there is checking for track shape. The shape of the etch track, how vertical the etch track is a key parameter in achieving good pin performance.
Several additional steps are required to complete a multi-layer flexible printed circuit. The individual panel layers are combined in a press. The multi-layer panel is then coated with solder mask or other coverlays to provide mechanical protection and minimize electromagnetic interference. Finally, the individual circuits are separated from the panel. In addition to unlimited length, I asked Philip about the other advantages of IHT.
That wire harness that we're replacing is essentially a passive interconnect. And we can convert that passive wire interconnect to a passive flex interconnect and save 60 or 70% of weight, so save a huge amount of space. However, it is a printed circuit board, and so it is also possible to add what we would call active components onto that flex, and really therefore change what is in wire can only be a passive interconnect into what flex can be an active interconnect. So you can have local signal conditioning, local sensing, so really to make the interconnect part of the active control of the system. So we see this as a really big opportunity for the technology.
Sounds like the advantages are pretty compelling. What applications are actually using the technology?
So we have started off in aerospace, and I still think that aerospace, the combination of the weight and space saving, and The particular advantages of multi-layer flex circuits, so incorporating signal shielding, are really suited to aerospace. But we're finding that electric vehicles, medical catheters, nuclear fusion, oil pipeline leak detection, really a very wide range of markets are finding the improvements of interest. So really, aerospace, electric vehicles, and medical catheters are the three major opportunities, but by no means the only ones.
Philip Johnston says the total market opportunity for Trackwise is wherever a wire interconnect is used. The challenge, he says, is to avoid behaving like a kid in a candy store and focus on those opportunities where IHT is truly differentiated. Now my colleague Pat Hindle takes you to Israel, home of Nano Dimensions, to explore its 3D additive manufacturing technology to produce PCBs.